have a look at question 3. This is a force and motion question. Okay, let's have a look. So two blocks A and B of masses 2m and 3m respectively attached to the ends of a light string. So we can label the weights. So 3m is a mass, so 3mg will be the weight. And then 2m is a mass, so 3mg will be the weight. And then, so that would be a tangent here and then tangent here. Yeah. And also, initially A is held at rest on a fixed rough plane. So if it's a rough plane, that means that would be friction. Yeah. And then the plane is inclined at an angle to the horizontal ground where tan alpha is 5/12. So I will draw a little triangle. So if this is alpha, so tan alpha is 5/12. So opposite is 5, adjacent is 12. So that means hypotenuse will be 13. So therefore, we have sine alpha is equal to 5/13, and then cos alpha is equal to 12/13. And then the string passes over a small smooth pulley. So if it's smooth, so this is important, yeah. So smooth means the tension on both sides of the string will be equal to each other. So because it's smooth, that's why if this is tangent, then this should be equal to that one. Should also be equal to tangent. Yeah. And then again, normal reaction will be equal and opposite. So there'll be another tangent here. So all of them will be equal. Yeah. So just be clear. So because there's a tangent, and then we know the normal reaction are equal and opposite. So therefore, that would be another tangent here. So those two are equal, it's just in opposite direction. And then because this is a smooth pulley, that's why the tension on both sides of the string will be equal. So because this is equal to T, that's why this is also equal to T. And then because, again, that would be an equal and opposite reaction. So this is also equal to that tension. Yeah. So that's how the force works in this case. And then the part of the string from A to P is parallel to a line of greater slope of the plane, and block B hangs freely below P, as shown in figure 1. And then the coefficient of friction between A and the plane is 2/3, so mu is equal to 2/3. The blocks are released from rest with the string taut, and A moves up the plane. So if A goes up, then B should go down like this. Yeah. And then we know friction should be always opposite to the moving direction. So that would be friction goes opposite to the moving direction. And then mu is 2/3, so that would be 2/3R. And then don't forget that would be a normal reaction R here, perpendicular to the plane. And then because like the particle is moving parallel to the plane, so we need to resolve the force either parallel or perpendicular to the plane. So we can resolve this 2mg, one perpendicular, another one is parallel to the slope. So this will be alpha, and then this will be 2mg times by cos alpha. And then this would be opposite. So it would be 2mg times by sine alpha. So that's what be the force acting on each, or the force acting on the system. Okay, and then the tangent in the string immediately after the blocks are released is T. Oh, we already labeled it T. And then the blocks are modeled as particles, and the string is modeled as being insensible. So A show that T is equal to 12mg/5. So let's set up equations. So just make sure these will be the force act on the particle A. And then those two tension will be the force act on particle P, the pulley. Yeah. And then this will be the force act on particle B. So to set up equation for particle B, we can do force goes down because this goes down. So we do force goes down minus force goes up equal to mass times by acceleration. And then for particle A, because particle A is go up to the slope, so we can do force goes up T minus force goes down, which is the friction 2/3R, and also 2 mg sine alpha goes down. So it'll be 2 mg times by sine alpha, which is 5/13. And then that's equal to mass 2m times by acceleration. And then, so because the particle is only moved in the direction which is parallel to the slope, so that means the force which is perpendicular to the slope should be balanced. So up should equal to down. So the force perpendicular to the slope, so which goes up is R, and then goes down would be 2 mg cos alpha, which is 12/13. So that would be three equations we need. Now we just have to solve them. So simplify, we have, we can just add the first equation and second equation to cancel out t, like what we normally do. Yeah, so add those two equations, 3 mg minus t plus t will cancel out, and then minus 2/3R, and then minus 2 mg times by 5/13. So that would be 10/13, because 2 times 5 is 10, and then mg is just mg. And that's equal to 3ma plus 2ma, which is 5ma. So all we did just add those two equations. So negative t plus positive t cancel out, and then the rest stay the same. We just simplified. And then now we have basically A we don't know, and then R we don't know. So we have to change R into 2 mg times by 12/13 to simplify. So 3 mg minus 2/3 times by R, which is 2 mg times 12/13. So 2 times 12 is 24. So we can leave as 24/13 mg, and then minus 10/13 mg. That's equal to 5ma. Then simplify this. So 3 mg minus 2/3 times 24/13 mg minus 10/13 mg. We could just put all in the calculator, because this is 3 mg and minus 2/3 times 24/13 mg, and then minus 10/13 mg. So put that in the calculator, 3 minus 2/3 times by 24/13, and then minus 10/13. So that would be just 1 mg. So mg equal to 5ma. So divide by m for both sides. So we have a is equal to g/5. And now we know acceleration. To work out the final answer, t, we can just substitute into any one of them. Clearly, this one is shorter, so we can substitute into this one. So we have 3 mg minus t equal to 3m times by a, which is g/5. So plus t for both sides minus 3 mg/5 for both sides. We have 3 mg minus 3/5 mg. So then tangent is just equal to, so 3 minus 3/5. That is just 12/5. So we have 12/5 mg. And that'll be the answer. Let's have a look at part B. So after B reaches the ground, A continues to move up the plane until it comes to rest before reaching P. And we want to determine whether A will remain at rest. Carefully justify your answer. Okay, so let's sketch a new diagram, because this time B already reached the ground, so it will be different now. So the diagram should look something like this. So B is already on the ground, so that would be particle B. So again, 3m B. And then particle A should move a bit more as B moves up. So particle A would be at this position. And then the instant when B reaches the ground, they should still connected by the light insensible string. Yeah. But because B is already on the ground, so B cannot move any further. But at that instant, A still have some velocity. So A should move up a little bit more and then stop. Yeah. So this is the actual position of A when it stopped. Yeah. So to label all the forces, because um, the instant when B underground, they should still be like light insensible string. They still be taut, yeah. But once B reach the ground and A continue to move a bit more, then they're not connected by a taut string anymore. So the string should become slack. So which means there'll be no tension in the string. So the only force acting on A, that would be the weight of A, which is 2 mg, and then the normal action act on A, R, and also we can resolve this one parallel, one perpendicular. So this would be like 2 mg cos alpha, and then this one would be 2 mg and then sine alpha. And also this time A completely stops at that position. So the only possible direction A could move is could go down or could stop here. Yeah. But either way, A should be on a point of move down. So it could be A move down the slope, or A is on a point of move down the slope, but because of the friction, A didn't. So it's still there. Yeah. So either way, friction should be opposite to that direction. So friction should be go this way, which is mu r, 2/3r. So to know whether A goes down or not goes down, we just have to compare the force in this direction. Because like particle A only moves in this direction. Yeah. So it should only look at the force in that direction. So the force goes down will be 2 mg sine alpha. And then we know sine alpha is equal to 5/13. So that'll be 2 mg times by 5/13. That's the force goes down. And then the friction would be 2/3 times by r, which is 2 mg cos alpha, which we know cos alpha is 12/13. So simplify this, we have 10/13 mg. And then simplify this one. So 2/3 times by 2 times by 12/13. That's 16/13 mg. And then clearly the friction is bigger than the downwards force. So that means particle A should remain at rest. As friction is larger than the downwards force. Okay. And then let's have a look at part C. So suggest two refinement to the model that would make it more realistic. So really you just have to see anything against the modeling assumption. So for example, the question says the string pass over a small smooth pulley. So you can see the pulley is not smooth. It has some friction. And then you can see, for example, the blocks are modeled as particles. You can see the blocks have dimensions. Yeah. So that means the center of mass is not in the middle. Yeah, it's not just on that dot. And also the string is modeled as being inextensible. So you can see the string are extensible. Yeah. So you just have to say anything to against them, or you can say like more accurate value of G. That always works. Yeah. Yeah, so just say something like this is fine. So one is because of 2 marks. So we say one more accurate value of G. Another one, you can say like a string can be extensible. Yeah, both works.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.